Hello, wonderful, amazing, fantastic geometry students. This is Ms. Youngblood here, and in this video, I'm going to be going through your Unit 5 test corrections. Before we get into the content, I just want to remind you that all assignments, Khan Academy assignments, test corrections, whatever you're trying to turn in to bring up your quarter 3 or quarter 4 grades, is going to be due next Monday, June 8th, at 11:59 p.m. Please reach out sooner rather than later if you need help getting caught up or completing any assignments. I'm available during all of my class sessions and available for office hours as well, as long as you schedule them in advance and we make an appointment. So please just make sure you're reaching out if you need help through text or email, and we will coordinate about the best way that I can assist you in bringing your grade up. Let's get into this now. So, our Unit 5 test focused on polygons and similarities. This first page is just focusing on polygons. These first two problems are using the interior angle sum theorem to figure out what the angles inside of these polygons have to add to. So reminder, the interior angle sum theorem is just a formula, and that formula is 180 times n minus 2, where n is the number of sides in the polygon. In our polygon for number 1, we see that we have 1, 2, 3, 4, 5 sides. N equals 5. To figure out the sum of all of the angles inside of the polygon, you just plug that 5 into the formula. So we're going to have 180 times 5 minus 2. And when you type that into your calculator, you get 540 degrees. So our answer for this first problem, 180, is 540 degrees. 540. And we can see that that is going to be the letter B. For your corrections, make sure you have written down what I have here for number 1, and you write a reflection about what we just did, what process did we use, and it needs to be at least 1 sentence long. If you have pictures of your actual test, you can also write what your mistake was. What did you do wrong, and what should you have done? So you could have said, I should have started by counting the sides of the polygon. Something like that. Simple, simple. Number 2. Number 2, we're looking at the same thing. So we need to start by figuring out how many sides we have in this polygon. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this polygon has 12 sides. It's called a dodecagon. Using the same formula, we're going to have 180 times 12 minus 2. 180, 12 minus 2 gets us 1800, or 1800. So this answer is going to be 1800 degrees, which means that if we had all the angles, all of these angle measures, and added them all up, we would get 1800 degrees. And that answer is going to be C. Okay. In the next section, we're building off of the same idea. So these next two problems ask us to find this missing angle. In order to find this missing angle, it would be helpful to know what all 4 of these angles add up to. To figure out what all 4 of these angles add up to, all we have to do is use the interior angle sum theorem. So we're going to start it off the same way. We know both of these shapes have 4 sides. So we're going to have n equals 4. And then we're plugging it into the same formula. 180 times 4 minus 2. So that's 180 times 2, which is 360 degrees. So that means that these 4 angles have to add to 360 degrees. To figure out this missing angle that we don't know, x, we can set up an equation. Our equation would be 115 plus 75 plus 85 plus x equals 360. Again, that's because we know all 4 angles have to add to 360. To start solving this equation, we need to simplify the left side, 115 plus 75 plus 85. We're combining those because they're all like terms. So we get 275 plus x equals 360. Subtract 275 from both sides. So we would get x equals 85, which is going to be D. Number 4, we're asked to do the same thing. We can skip this first step because we know we're going to get the same answer because both shapes have the same amount of sides. So we already know that these 4 angles, including this missing angle x, have to add to 360. So 70 plus 117 plus 115 plus x equals 360. Combine like terms. 70 plus 117 plus 115 gets us 302 degrees. 302 plus x equals 360. We can subtract 302 from both sides of the equation. So that gets us x equals 58 degrees, which is A. So again, make sure you write the corrections I've written. You don't need to draw the pictures, just write the math that I've written and reflect. What did we do? What was our first step? Or what did you mess up on? In this next section, we are asked to find the area of these given polygons. In order to do that, we need to identify what the polygons are, what their area formula is, what values were given, and then plug them in to solve it. So, this first shape, we have 2 pairs of parallel sides. These sides are parallel, and these sides are parallel. However, it's tilted. Because it's tilted, this shape is going to be called a parallelogram. The area formula for a parallelogram is base times height. So area equals base times height, where the base is one side length, and the height is the distance from the opposite side or vertex to that side length. So in the way that this figure is drawn, our base is going to be 11. So we're going to have 11, and our height is the side that is perpendicular to that. It makes a right angle, and it's going to the opposite side. So that height is going to be 10.4. So to find the area in our calculator, all we have to do is 11 times 10.4, and that gets us 114.4 square inches. And we can see that's going to be letter D. These problems as well, you don't need to draw the shape. Just write the formulas, write the math we're doing, and make sure you have the final correct answer. Number 6, again, 2 pairs of parallel sides, but now all 4 angles in the right, in this shape, are right angles. So because we have 4 right angles, this is going to be a rectangle. The area formula for a rectangle is very similar, exactly the same, to the area formula for a parallelogram. So it's going to be the area is the base times the height. Again, the base and height are the 2 sides making the right angle. So the base, the way this figure is drawn, is 10.8. So we're going to have the area is 10.8 times our height, which is 8. So in our calculator, 10.8 times 8 gets us 86.4 square centimeters. Seven and 8, same process. Identify the polygons. Oh, sorry, excuse me. So number 7, for our first polygon, we see we have 3 sides, so that means our first polygon is going to be a triangle, and the area formula for a triangle is very similar to the area formula for a rectangle. When we're given a rectangle, in order to form a triangle, you simply cut the rectangle in half. Therefore, the area is going to cut in half for the triangle. Area starts off the same, base times height, but you divide it in two, or divide it in half. In this specific triangle, our base and height are the two lengths that make a right angle. So based on this diagram, the base would be 11, and the height would be 4.9. And again, that's because that side is making a right angle with the base. In my calculator, I'm going to do 11 times 4.9, which gets me 53.9. Dividing that by 2 gets us 26.95. So the area for this triangle is going to be 26.95 square yards, which we see is the letter C. Number 8, our final polygon. We only have one pair of parallel sides, and there are 4 sides in this polygon. This polygon is called a trapezoid. The area formula for a trapezoid basically combines the area formulas for a rectangle and a triangle, because a trapezoid is comprised of rectangles and triangles. You see here, if we were to draw a line here, I am going to erase this, but I just want to briefly show you. See, we have this rectangle, 2.7 by 5.4, and then we see we have these two triangles that can be mushed together if you wanted to clearly see where the formula comes from. But regardless, the formula is going to be the height times the sum of the two bases, base 1 plus base 2, divided by 2. For this particular trapezoid, the height is going to be the length that connects the two bases, which are their parallel sides. So our height is going to be 5.4, and our two bases are going to be 8.7 and 2.7. And then we're going to divide all of that by 2. So our area is going to be 8.7 plus 2.7 times 5.4 divided by 2, 30.78 square inches. In this next pair of problems, we are asked to find the scale factor from the smaller figure, or the black figure, pre-image, to the blue figure, our image. So we're given this pre-image original triangle, triangle JKL, and we're asked to see what was multiplied to this pre-image JKL to get our image, or our new figure, J prime, K prime, L prime. So how do we go from here to here, basically? In order to do that, we want to identify a pair of corresponding points. So let's say we're focused on the points K. You do not have to draw this picture, but I do want you to write this math. If we're focused on point K, the original K was 1, 2, 1, 2, and the new K was 2, 4. So we need to determine how did we go from here to here. When you are scaling up figures proportionally, you're doing that with multiplication or division. We are not adding, because that does not change both values proportionally by the same amount. So let's say we wanted to say, oh, well, to go from 1 to 2, I would do 1 plus 1 gets me 2. That's not going to work for the y values, because 2 plus 1 does not get you 4. So again, we're using multiplication to scale up or scale down these figures when we're talking about dilations and similarities. To go from K to K prime, we can clearly see that you would multiply by 2. However, if we got into a specific scenario where it wasn't as clear to see, so if you're multiplying by a fraction or decimal, an easy way you can figure out the scale factor is by dividing the image by the pre-image, or the new over the old. So our scale factor K can also be found by doing the x values, 2 divided by 1, or the y values, 4 divided by 2. Whichever you choose, your final result would be 2. So we can see our scale factor is 2, which means our final answer for this problem number 9 is going to be D. I know I explained that in a lot of detail, but I just want to really make sure we understand what scale factors are. So again, the only work you need to show is what we did here, something like this, and also make sure you're doing your reflection for this problem. Number 10, we're doing the same thing. Pick a pair of points to analyze. I'm going to pick my T points down here. I originally looked at my U points, U and U prime, but I noticed U prime is not on a grid line, so this would be a decimal. You can work with the decimal, but if we're given some grid lines to work with, you might as well work with those hard numbers. So our focus point is T. The original point T is -2, -2. T prime is going to be -3, -3. So this is kind of the example I'm talking about. It's not really as easy to see what you multiply -2 by to get to -3. So in order to find that, we're going to use this process we use for number 9. Our scale factor K is going to equal the new value, -3, over the old value, -2. For this particular problem, both x values and y values are the same, so this could either represent me choosing to focus on the x values or the y values. I don't have to do both like I showed in number 9. In our calculators, -3 divided by -2 gets us 1.5. So the scale factor is going to be 1.5, which means our final answer for number 10 is going to be C. In this next pair of problems, we have to use the given scale factor to dilate the original figure. So dilations mean that we're either going to scale up the figure, make it bigger proportionally, or scale down the figure, make it smaller proportionally. So everything should be changing by the same factor or amount. So for this first problem, number 11, our scale factor is 2, so that means our figure should be getting bigger, it should be scaled up by 2. So we're going to multiply each of these original points by 2 to find the new points. Our first point, B, the original point is -2, 0. Multiplying by our scale factor changes this point to -4, 0. Our second point, C, the original point is 2, 2. Multiplying by our scale factor 2 is going to change this point to 4, 4. Again, all I'm doing is multiplying both of these values by 2. -2 times 2 is -4, 0 times 2 is 0. 2 times 2 is 4, 2 times 2 is 4. For our last point, D, we are given the point 1, -1. Again, multiplying by our scale factor 2 is going to change that point to 1 times 2 is 2. -1 times 2 is -2. So these are our new points, -4, 0, 4, 4, and 2, -2. So we see -4, 0, 4, 4, 2, -2. This answer is going to be B. Now, for your reflections or your corrections, all you need to do is write this part. For your reflection, I want you to basically summarize what we did here and tell me how we're going to graph our first point. So our first point, or any of the points. Our first point is negative 4, 0. So we're going to go left 2, left 4, and then don't go up or down. Our second point is 4, 4. So that means go right 4, up 4. This point here. Third point is 2, negative 2, right 2, down 2. This point here. Connecting our 3 points shows us that we have the same triangle, same ratios of side lengths. It's just made bigger. So the shape looks exactly the same, it's just bigger, which means that we have a similar figure. Next problem 12 is very similar. Our scale factor is now going to be 2.5. So we started the same way, writing out your points. So our first point we focus on is L. The coordinates for L are going to be 2, 2. As we said, our scale factor has changed for this problem. So instead of multiplying by 2, as we did in the previous problem, we're going to multiply by our new scale factor, 2.5. So multiplying both the x and y value by 2.5 gets us our new point, 5, 5. Continuing this process with our next point, M. The coordinates for M are 2, negative 1. We're going to multiply that by 2.5. 2 times 2.5 is 5. Negative 1 times 2.5 is negative 2.5. Our last point, K, has the coordinates negative 1, negative 1. Multiplying that by our scale factor 2.5 gets us the new coordinates, negative 2.5, negative 2.5. So we're going to plot these points in the coordinate plane. 5, 5. Right 5, up 5. M is right 5, down 2.5. And K is left 2.5, down 2.5. Connecting these 3 points shows us that we have a similar triangle. Same shape, different size. And our final answer for number 12 is going to be, so K, if I look at K, it says K is negative 2.5, negative 2.5, so it has to be this answer, B. In this next pair of problems, we are still building off of this idea of similar polygons. So we're still looking at shapes that are scaled up or scaled down by the same amount by using either multiplication or division. So for number 13 specifically, we need to figure out if this polygon was scaled down to this polygon, what does this side length, this polygon was scaled down to this polygon. What does this new side length need to be? In order to do that, the easiest method we can use is a ratio table. So let's start by identifying what our corresponding side lengths are. What sides match up? This side length 18 is going to match up with this side length 3. Now we already know that we are asked to find this missing side length. We can call it x. And we can see that it corresponds with this side length 24. So these two pairs of side lengths need to be scaled down by the same amount. In order to see that, we can set up a ratio table. So our original figure has the two side lengths 18 and 24. We know that 18 needs to change to a 3, and we know that there is a simple number we can divide by to go from 18 to 3. So if we scale down the 18 by dividing it by 6, we would get that side length 3, and we have to make sure we are scaling down by the same amount with this other side length 24. So if we divide this side length by 6 as well, we would realize that this missing side length x has to equal 24. or 4, excuse me, because 24 divided by 4 gets us 24 divided by 6 gets us 4. So our final answer for this one is C. Let's try this again with number 14. Start by identifying your corresponding side. So we're working from this rectangle to this rectangle. So this side, 34 or 30, is going to match up with 24. And this side, 20, is going to match up with our missing side length x. Setting up our ratio table, we have our original polygon, which is 30 by 20. And we're trying to change the 30 to a 24. Now this one is not as straightforward as the previous problem, right? In this problem, we could just see that we divide by 6 and we get 3. There's no whole number we can divide 30 by to get right to 24. So we might have to scale it down a bit too far at first and then scale it back up. So we want to look at 30 and 20. Think about a number we can divide 30 and 20 by. Well, the first number that comes to my head is 5. You could have also divided by 10. So dividing 30 by 10, scaling 30 down by 10, okay, let's do 10, gets us 3. And scaling 20 down by 10 gets us 2. So we've scaled down this 20 by 30 rectangle. I'm going to sketch this to a 2 by 3 rectangle. These two rectangles are similar because they have been scaled down by the same amount. They are proportional. Their side lengths are still proportional. But now we want to scale up that 3 by 2 rectangle I drew here to a 24 by blank rectangle. And we need to figure out what this side length is. So we're still trying to change this 3 now to that same 24. So to scale up 3 to 24, we know we would multiply by 8. And we have to make sure we're doing the same thing on the bottom to maintain the proportions of the rectangle. 3 times 8 gets us 24. I don't know why I wrote a 2. 2 times 8 gets us 16. So our missing side length is going to be 16, which is A. So for your work for these, again, you don't have to draw the shapes. Just show the ratio table or some kind of work. You could say 18 divided by 6 is 3, 24 divided by 6 is 4, something like this, to show that you understand why this side length has to be 4 and why this side length has to be 16. These next pair of problems are very similar, but now once you figure out what the missing side length has to be, you have to set it equal to this expression and solve for x. So there's one additional step, but we're still going to start them the same way. So again, we're going to start by identifying the corresponding side lengths. So we see, so I do want you to notice something. We're given this side length 6, which is cool, but we're not given this side length here. So that's the reason why we wouldn't want to focus on the 6. So we're going to ignore the 6, but this side length 10 corresponds to this side length 5. So we know we need to use that relationship. We also know that we need this side because it has our variable we're trying to solve. And we see that it matches with this side, 8. So now we can set up our ratio table. In our original polygon with the 2 known sides, we have the 5 and the 8. And we are trying to change them into the values on the unknown polygon with our variable. So we know the 5 needs to go to 10. Well, to take 5 to 10, we can scale it up by a factor of 2. 5 times 2 gets us 10. 8 times 2 gets us 16. Because we need to ensure that we are scaling up by the same amount for all side lengths in this shape. So that means this side length here has to be 16. So instead of just saying x equals 16, we're going to say 5 plus x equals 16. Subtracting 5 from both sides shows us that x has to equal 11. So this answer for 15 is going to be C. 16, again, very similar. Match your corresponding side lengths. in our known rectangle, we have the 16 is going to match up with the 40, and the 8 is going to match up with the x plus 11. So let's start with our known rectangle, 16 by 8. So to start off our ratio table, we're going to have 16 and 8. And we know we're trying to change the 16 to 40 and the 8 to whatever it ends up being. So to change the 16 to 40, there is no whole number we can just multiply 16 by to get 40, so we need to scale it down a bit first. Let's try scaling it down by 2. So dividing 16 by 2, we have to make sure we do the same thing with the 8 to keep the sides proportional. 16 divided by 2 gets us 8. 8 divided by 2 gets us 4. So we have scaled down this 16 by 8 rectangle to an 8 by 4 rectangle. Now we need to scale it back up so we can have a 40 by whatever this side length must be. So to scale up the 8 to 40, we're going to multiply by 5. We also need to multiply the bottom by 5. 8 times 5 is 40. 4 times 5 is 20. So we have scaled up we have found the proportional or the similar rectangle to this, 40 by 20. So this side length, x plus 11, has to equal 20. Subtracting 11 from both sides gets us an x value of 9. So this answer will be C. In this next set of problems, we are asked to determine if a pair of triangles are proportional or if they are similar by studying the proportionality of their sides, so seeing if their sides are scaled up or scaled down by the same amount, and focusing on their angles. So for this first problem, 17, we see we're given 2 triangles here. And the key thing with these triangles is they're not as straightforward as the previous problems. So we see they don't have the same orientation. They're not placed in the same way. They're tilted, they're turned, rotated, to use our transformation vocab. So we want to determine if these 2 triangles are similar by looking at their side lengths, seeing if they're proportional like these were, and we're able to scale up and scale down by the same amount and still get the same lengths for the triangles. So let's go ahead and identify our corresponding sides. So this side, 10, is going to match up with which of these sides? So this is why these are a little bit trickier. It's not as easy to see because obviously this 10 doesn't match up here because the 72 is down here. So this 72 for sure matches up with this angle, and the 10 has to match up with the 70. One way you could visualize that is by taking this triangle and rotating it. Another way you could do it that makes sense is 10 is the smallest side between 10 and 11. 70 is the smallest side between 70 and 84. So it wouldn't make sense for 10 to go from the smallest side that is given to the biggest side that is given. Small has to go to small and big has to go to big. So the 10 and the 70 are corresponding sides, and the 11 and the 84 are corresponding sides. So now we want to use our ratio table. If we're starting with the triangle that has sides 10 and 11, we want to figure out what do we scale 10 up by to get 70, and is that the same number? And when we multiply by that same number, how are we going to get that 84? So to go from 10 to 70, we know we would scale up by 7, right? 10 times 7 gets us 70. We need to scale up the bottom or the other side by the same amount in order for the 2 triangles to be similar. 11 times 7 gets us 77. So we can say 77, let me use my orange because that's the color we use for that side. 77 does not equal 84. So that's why these triangles would not be similar. So these triangles are not similar because the 10 and 11 are not scaled up by the same amount in order to obtain the side lengths that are given in this triangle. So 17 is no. Number 18, we are actually given all three sides of the triangle. So we're still going to set up our ratio table to see if they're similar. But actually, so I think when we taught it in class, I didn't officially teach you guys side similarity. So I'm going to focus on using the side angle side similarity. To use the side angle side similarity, that means we need to show that two side lengths are similar and the angle between them is similar. So first we want to identify what angle could we possibly say is equal between these two triangles. In this triangle, it had the potential to use the side angle side similarity theorem because we saw that these angles were congruent because they were given, and we were given these pairs of side lengths to analyze. They just weren't proportional. In this triangle, it might be a little bit harder to see the two triangles. So we have a larger triangle, HFG, that's our larger triangle, and a smaller triangle, KFL. So we want to see if those two triangles are similar. In order to do that, we can, by using the side angle side similarity, we need to identify what angle we have the potential to say is what pair of angles are congruent. This angle F is the same angle, right? So this angle F, no matter what it is, has to be equal to this angle F in the smaller triangle. So you can say in this color that angle HFG in our larger triangle is congruent to angle KFL in our smaller triangle, and that's because they are the same angle. So we already have our congruent angles criteria, so that's what we just took care of, the A. Now, to take care of the two sides, we need to do the same thing we did here. So although we're given three sides, we want to really focus on the two sides that are adjacent to or touching this angle. That's these sides, HFKF and FGFL. So for our larger triangle, this side length, HF, is going to be 6 plus 18. So, oh, I had that purple already. HF is going to be 24. And then this larger side length for our larger triangle, FG, this whole thing is going to be 52. So for a larger triangle, we have the side lengths. Let's go small to large because that will be might be easier with multiplication. Smaller triangle, we already know we have 18 and 39. So in our smaller triangle, we have 18 and 39. And we're trying to scale the 18 to 24 and the 39 to 52. So we can't go, there's no number we can multiply 18 by to go straight to 24, so we're going to need to scale it down first. We want to try to think, what can we scale down 18 and 39 by? So we can scale both of those numbers down by 3. So dividing 18 by 3 and 39 by 3 gets us 6 and 13. Then we want to scale up this 6 to 24 and this 13 to 52. So to scale up 6 to 24, we can multiply by 4, and we have to make sure we do the same thing down here, times 4. 6 times 4 is 24. 13 times 4 is 52. So we have shown that these pairs of side lengths are proportional. They are scaled down and scaled up. They are multiplied by the same amount in order to go from one to the other. So therefore, we can say these two triangles are similar by side angle side, which is going to be letter C. The next two problems in our set We're still going off the same idea, trying to prove that these two triangles are similar using the similarity theorems. However, they don't give us any side lengths to work with. So the only option we have is to try to prove that two pairs of angles are congruent in both of the triangles, and that will be enough to prove that the two triangles are similar. So starting with number 19, we're given these arc markings, which represent congruence. So we're given 3 arc marks here for D, and there's no other angle that has 3 arc marks at this moment. So that means right now, D is not congruent to any of these angles. We're given 2 arc marks for C, and again, none of the angles in this triangle have 2 arc marks. So right now, we cannot conclude that C is congruent to any of the angles in this triangle. This angle B does happen to be congruent to, so this angle, I should call it CBD, does happen to be congruent to this angle NBM. Maybe I should I'll put the little tick mark, because they are vertical angles and they're across from each other. However, this only shows that we have one pair of congruent angles between these two triangles, not 2. So there's no way to prove that these 2 angles are congruent to either of these 2 angles. Therefore, these 2 triangles are not similar, so this one is going to be no. So what you can say for your work, again, you don't have to draw them. Just make sure you're writing what I write. You can say angle DBC is congruent to angle MBN because they are vertical. However, that's only one pair of congruent angles, and we need 2. So this one is no, and I believe that that was letter A. So these 2 triangles are not similar because we can only find one pair of congruent angles. The same idea applies here with 20. We need to find 2 pair of congruent angles. I always start with looking for some vertical angles. So we can see here we have a pair of vertical angles. So we see angle VJU. Angle VJU is congruent to angle KJL. Angle KJL. And that's because this pair of angles are vertical. And we actually are able to find another pair of congruent angles. And that's because we are given parallel sides. So at the beginning of the school year, we learned that parallel lines are very special because they create congruent angles. So if these are 2 parallel lines, we know they're parallel because of these red arrows here. So these are 2 parallel lines. We can extend them a bit. We can draw this line as their transversal. Could have chose the other line as well. I just happened to choose this one. And we can see we have some angles in here. So I'm going to draw my angles in pink. So we have these angles, draw some in purple, these angles, and those are the angles that are actually relevant because you're actually touching the triangle. We do have some more angles out here, but they're outside of the triangle, so I'm not really going to touch much on those. But we see we have this pink pair of angles and these purple pair of angles. The pink pair of angles are more meaningful because they're both inside the triangles, and we know that these pink pair of angles are actually congruent. Let me actually be more precise with the number of arcs that I'm putting. So again, because these lines are parallel, we know these pink pair of angles are congruent, and these purple pair of angles are congruent. We're focusing on the pink. These angles are angle VUJ and angle LKJ. And these angles are congruent because they are both inside of the parallel lines. So they're inside the parallel lines and on opposite sides of the transversal. So they're congruent because they are alternate interior angles. Because we found 2 pairs of congruent angles, we can say that these 2 triangles are similar by angle, angle. So angle, angle, similarity. And that's going to be B. finally made it to the last page of the test, guys. We're almost there. We can see the light. I'm trying to show you the light. Okay, so for 21 and 22, these are story problems. So they're basically the same idea we've been working with. They're just phrased in a different way. And it's actually asking you to apply the concept we've been focused on for this test. So for number 21, it says you're reducing a poster for flyers. So think of like a rectangle to represent the posters. Let's draw a rectangle. The original size of the poster, so draw our original poster. They say it's 30 by 15 centimeters. So we have a big poster that's 30 by 15, and we're trying to shrink it down. So we want a smaller one for some flyers to pass out to people, and we want it to be 6 by 3. And they ask us to find the scale factor of the reduction. So it's throwing some vocab words at you. Remember, enlargement means a figure or, a figure is getting bigger, and reduction or reducing something means it's getting smaller. But because they ask for scale factor, you do still want to tell what is being multiplied in order to reduce the original poster to the flyer. So we can see that to go from 3 divided by 6, or to go from 3 to 6, or 15 to 3, we would divide by 6, by 5, divided by 5. So 15 divided by 5 gets us 3, 30 divided by 5 gets us 6. So this is our scale. This is what it's being scaled down by. We're divided by 5. However, to find the scale factor, we need to recognize that dividing by 5 is the same thing as multiplying by 1/5. So whenever you're dividing by something, that's the same thing as multiplying by the reciprocal. So that means our scale factor is going to be 1/5. Multiply by 1/5 to get from our poster to our flyer. And this is literally the only work you need to show for 21. 22. You are viewing an object that is 7 millimeters in the magnifying glass. So the original size is 7 millimeters, and the magnifying glass enlarges the object by a scale factor of 30. So it's going up by a scale factor of 30, so that means you're multiplying by 30. And we want to find the image, the new one, after it's scaled up by 30. So all you would do is 7 times 30. 7 times 30 gets you 210 millimeters. So that's our answer. And again, that's the only work you need to show. 7 times 30. You can draw the little picture I drew if you want, but you don't have to. Also, if you have not been, make sure you go back and do your reflections. So for 21, just describe what we did here. How did we, where this divided by 5 come from? How did we change it? Just give me at least one sentence describing what we did. In 22, you can literally just say, what math did we do down here? What did we do? Everything works for me. In this next section, we are asked to perform similarity transformations. So a similarity transformation involves a dilation of some sort, so either the figure is getting bigger or smaller, and an additional transformation. So I think it was in Unit 3 at the beginning of the school year, we learned about the 3 forms of transformations: translations, reflections, and rotations. So a similarity transformation involves one of those 3, which are called isometries, as well as making it bigger or smaller. So that's what we're doing for this next section. In this first problem, 23, we are asked to dilate the figure by a scale factor of 2 and then rotate it 180 degrees. So it does call on some of that previous knowledge from the 3rd unit. So start by dilating. We're going to go ahead and identify our points. Our I, we see is 0, 2. And we're scaling it up by 2, which gets us 0, 4. Our H is 2, 2. Scale that up by 2, 2, 2, and we get 4, 4. Our J is -1, -1. Scale that up by 2, and we get -2, -2. So this represents the dilation, this multiplication by 2. So let's go ahead and plot those new points. I is 0, 4. H is 4, 4. And J is -2, -2. Left 2, down 2. So again, no need to draw the picture, but make sure you have the points written. The next part is to rotate each of these points by 180 degrees. When you are rotating by 180 degrees, that means you just change the signs on both the x and the y coordinate. So 0, 4 is going to go to 0, -4. 4, 4 is going to go to -4, -4. And -2, -2 is going to go to +2, +2. So we have 0, -4, -4, -4, and 2, 2. Connecting our dots produces the same shape as the original, but the figure has been dilated, it's been enlarged, and it's been rotated. So that is the similarity transformation. Our next problem is 24. So again, we're going to start with dilation. Write your original points. V is 0, 1. So dilating that by our new scale factor of 4 is going to get us 0, 4. Our next point, U, U is 0, 0. Dilating that also gives us 0, 0. W is 1, 0. Dilating that gets us 4, 0. So let's plot our new points after our enlargement or our dilation. V is 0, 4. U is actually going to stay the same, and W is 4, 0. So we see we have our triangle, same shape, but it's been scaled up to a different size. The second part of our similarity transformation is a translation. So that means we're going to take this green triangle and shift it. When it says x minus 3, that means we're going left 3 and down 5. That also means we're subtracting 3 from the x value and subtracting 5 from the y value. So our new point for V would be left 3, down 5, puts us here. Is that, oh, I did the original V, yes. You want to make sure you do the new V. So we're here. So work with this point. Left 3, down 5. That doesn't make sense. So it's going to be -3, -1. U is still 0, 0. Left 3, down 5. Gets us -3, -5. 4, or W is 4, 0. Left 3, down 5. Gets us 1, -5. So this is our final figure after it has been dilated and translated. So the last problem in this section, we are still asked to dilate our figure using this scale factor and perform our last isometry or transformation that we learned about, which is a reflection. So we're going to start with the dilation. Our original points are G, which has the coordinates 2, 1, F, which has the coordinates -1, 0, and H, which has the coordinates 2, -1. And we're going to multiply by this new scale factor. So when we're given a scale factor as a fraction, we have two options. We can multiply by the number in the numerator and divide by the value in the denominator. So we could do 2 times 3 divided by 2 gets us 3. Or you could just change this to a decimal and multiply by the decimal. So changing this to a decimal gets us 1.5. So we're multiplying all of our points by 1.5. 2, 1 multiplied by 1.5 gets us 3, 1.5. -1, 0 times 1.5 gets us negative 1.50. 2, negative 1 times 1.5 gets us 3, negative 1.5. So our first point G is going to go to 3 up 1.5. Our second point F is going to go negative 1.5, 0. Third point H is going to go to 3, negative 1.5. Connecting point. And that is our figure after the dilation. For the second part of our similarity transformation, we need to reflect these points over the y-axis. So we're reflecting over the y-axis, which is here. So we want to look at how far away these points are from this line. So this first point for G is 3 away from this line. So when we reflect it over this line, we have to make sure that it's the same height, but the same distance on the opposite side. So we're just going to kind of imagine drawing this to our line of reflection, and then we're going to go the same distance in the opposite direction. So basically G is 3 away from the line of reflection, so we have to go 3 away from the line of reflection, 3 to the right, so we go 3 to the left for our new G. So that new point for G is going to be negative 3, 1.5. The new point for F is 1.5 to the left, so we're going to go 1.5 to the right. So our new F is going to be 1.50. And our new H is, again, 3 to the right, so we're going to go 3 to the left. So our new point for H is negative 3, negative 1.5. And this is our final figure after our original figure was dilated by 1.5 and reflected over the y-axis. Our last problem on the test, number 26. So it is actually just a repeat of one of the previous problems we had using our ratio tables. So we're going to start by identifying our corresponding sides. We see, again, I want to emphasize, we have this 23, but we don't have the corresponding side. So that is why we're not going to focus on 23. We have 15, which corresponds to 9. And we have 25, which corresponds to 2x plus 1 for this missing side that we're going to find. So we need to figure out, well, how are we scaling 15 to 9, and what does that mean the 25 has to change to? So we're going to write the side lengths of our original figure, or original polygon, 15 and 25. And like we said, we're trying to change 15 to 9. There is no number we can multiply, there's no whole number we can multiply or divide by to get 15 to 9, so we're going to want to scale down. So we want to scale it down a bit too much first and then scale it back up to 9. So looking at 15 and 25, the first number that comes to my head that I can divide both of those by is 5. So we're going to divide the top and the bottom by 5. 15 divided by 5 gets us 3. 25 divided by 5 gets us 5. So for this polygon, we have scaled down those two sides to 3 by 5. So if I was to sketch the new polygon, which will not be perfect by any means, this side would now be 5 and this side would be 3. So now we're scaling this polygon up to this one. So now we're going to scale up this 3 by 5 polygon to this 9 by new-sided polygon. I didn't say that already. So to scale up 3 to 9, we need to multiply by 3. So we're going to multiply by 3 on the top, and we have to do the same thing in the bottom to keep our sides proportional. 3 times 3 is 9. 5 times 3 is 15. So that means this bottom side, 2x plus 1, has to equal 15. So let me erase this. This is just in the way, just a visual representation. The equation we need to solve is 2x plus 1 equals 15. Subtract 1 from both sides. So 2x equals 14. Divide by 2. x equals 7. And that concludes our test corrections. If you have not already, please take the time to go back and do your reflections in addition to your corrections. I hope you found this video helpful. Please keep in mind that all corrections, Khan Academy assignments, whatever you're still turning in to bring up your grade, are going to be due on Monday, June 8th by 11:59 p.m. If you need help getting caught up on anything, just know I'm here. You can come to office hours that you could set up individually, or the class sessions and office hours that I have scheduled. Like there's something I'm missing, but I can't remember. So if you have any other questions, you can feel free to text me, email me, just reach out if you need help, and I will make myself available at my earliest convenience. I thank you so much for taking the time to watch this video, and I miss you, and I look forward to hearing from you or seeing you soon. Bye.